Hi everybody, John Bellameric here again. Talk to you a little more about Nephio. In this case, we're going to build out our demo environment. So for those of you who did not watch the demo video, I'm going to talk a little bit about what it is we're actually building out. If you may have jumped past the first 3 episodes, which are more explanatory, which is fine. We don't make those a prerequisite to this, but I think you'd understand a lot better what you're going to be doing with the demo if you go back and watch those. So for those of you who jumped ahead, you may keep in mind you may want to go back and check out those other things. So normally, in a sort of production environment, Nephio would be deployed. The Nephio components themselves would be deployed in a cluster, and then Nephio would be used to provision other clusters and to provision workloads across all of those clusters. In our demo environment, to keep things well controlled and easy to sort of take people through exercises and sort of have a kick the tires environment, we just do everything in one VM. We use Kubernetes and Docker as our cluster provider, and that way we can run multiple clusters within a single VM and not have to worry, about the broader context. So what we're going to have at the end of this video is a VM set up with a Nephio management cluster and these different components running in it. So the Nephio components themselves consist of the web UI, the Nephio controllers. These are Kubernetes controllers that perform operations we need within Nephio, and a couple of other components for our GitOps. So config sync is a GitOps agent that it's a Git syncer, takes things from Git and applies them to the API server, and Porch is a package orchestration engine for manipulating packages, which we'll see later. In addition, we have a number of components that in a production environment you would probably get from an external service. So for example, we have Metal LB running in here that provides the load balancing for our kind clusters, or at least for the management cluster. We don't run it in the other clusters today. But normally that might be your cloud provider management, our cloud provider load balancer, for example. Similarly, we run Gitty, which is an open source Git provider. In a production environment, you may host Gitty yourself, you may host Gitty on some third-party service, you may use GitHub, you may use GitLab, you may use Google CSR, you may use some other third-party or self-hosted Git provider, but for simplicity, we embed it here in the demo environment. We also implement Cluster API, so CAPI. Cluster API is an open source project from Kubernetes that enables you to use Kubernetes management techniques to provision clusters. We use it to provision kind clusters. There are other kind of clusters you can provision with it, which you could do with Nephio. We don't have examples yet built for that, but you could do it with the existing Nephio code. In a production environment, again, you might use something else. There's a lot of different projects for provisioning clusters in cloud services, so each cloud provider tends to have their own. So Google has what we call Kubernetes configuration connector that allows you to do this. Crossplane is a sort of universal abstraction engine for these kind of APIs you can use to provision clusters. Amazon has, I think, something called AWS controllers for Kubernetes or something like that, that allows you to do this in provision EKS clusters. Microsoft has a similar thing. So there's many different options there for provisioning clusters, but for our demo environment, we just use CAPI. The other piece here we call backend, our backend resource allocator. So this is something that that we have within, we deploy within the Nephio management cluster. Something Nokia, one of our community members, provided. But essentially what it is it's a generic engine for allocating resources like IP addresses and VLAN IDs. And in a production environment, this more than likely would be a proprietary, off-the-shelf IPAM system or potentially a bespoke IPAM system that your organization has built internally that you would make these allocations from. But it's here to demonstrate how Nephio can integrate with systems owned by other parts of your organization. So we've talked a lot about the cooperation between teams. This is there to demonstrate that concept of you have a network planning team and they want to control their data and they want to provide an API for us to get that data, and we don't have to coordinate ahead of time with them. That's the idea. So that's what we're going to provision. So let's get started. So I have a terminal here. Actually, before I go to the terminal, let's look at this. So this is the UI, or rather, this is the GitHub repository. You see, it's the. Let me switch to that window. What you can see here is this is the github.com nephio-project/docs. You'll find these links everywhere. I'm going to switch to the v1.0.1 tag so that we don't get anything that's sort of in progress and maybe not working or not correct. So this is the documentation, and in particular, we would drill into in this case, this demo sandbox environment installation. And the first thing I will show you is I will provision the easiest way, which is simply we have, well, what we've done to provision this demo environment is we have a script that you can run on really any Ubuntu 2.0.0, 2020-04 LTS version is the one we're using. You could actually do this if you're in GCE. It's super easy. You can just do it with this one command. I am sure that the other clouds would have a similarly easy command. I just don't know them. So I'm going to do this, and then I'll also show you how to do it. If you already have, you just provision an Ubuntu VM yourself, and then you can go ahead and run the script, and I'll show you that after we do this one. So the first one, I'm just going to this page, I'm copying this directly. I go to my terminal, and I already have in my terminal set up gcloud. Gcloud is Google's CLI for the cloud. So I'm just going to go ahead and paste that in. What is this doing? It's creating an instance of type E2 standard 8. So we're going to simulate a number of clusters within this environment. So we do need, a fairly robust VM to do that. We want 200 gigs of disk. We want 8 CPUs, and I think we look for like 32 gigs of RAM. So the idea there is that we need all that RAM to simulate many clusters. So this tells Google where to get the image, and then we have this startup script URL. So this is just downloading this file directly from GitHub at boot and executing the script. So let's just run that. Okay, so this is going to take a while. So I'm going to pause the, see, I don't have this configuration set up. Okay, let's try that again. And actually, let's call this something else. Okay, so it's starting to spin that up. In fact, while that's running, I'll show you. If we go back to the. One second. Let me go back to this. We do talk about in here. You can follow the installation. So what I can do is I can watch it. So let's just see. It takes a minute for the VM to start running, but once it starts running, I did change this name. Okay. All right. So what this is going to do is just attach to that VM, and it's going to follow the startup script as it runs through. And once we see it attach, okay, you can see there it is. It's running. It's going to go through and provision a bunch of stuff on there. And what we're going to have in the end is that picture we started with. So I'm going to pause the recording here. And we'll come back in a few minutes. Okay, I'm back again. So it's all done now, you can see, with provisioning that. So let's take a look again at some of the things we do next. So once the provisioning is done, all of that stuff we saw in that picture is already set up, but we need to be able to access it. So since we're running in a kind cluster inside of a VM, those IP addresses to get access to the UI and things like that aren't just available. They have to be exposed via a tunnel. So what we do is we have access to the user interfaces here. This tells us how to do that. So there's two UIs we might be interested in. One is the Nephio web UI, and that's running inside Kubernetes, but it's not exposed on a load balancer IP address anywhere right now. So we have to both tunnel with SSH into the VM, and we have to port forward within Kubernetes. So we'll do both of those things in a minute. The other UI we want to show is potentially look at is the Gitty UI. That one we do expose on a load balancer IP address within the VM. And so we don't need to do the Kubernetes port forwarding, but we do need to do the SSH port forwarding. So this SSH command, basically what it says here is SSH into that particular VM that we just created, and forward from the VM's localhost 7007. So this DNS name will be resolved in the context of the host that we're SSHing into, and put that on port 7007 of our local workstation. Similarly, port forward from our port 3000 to the IP address 172.18.0.200, which is where we put Gitty, port 3000. So we're just mapping the ports on our local workstation into those IP port combinations on the VM. So that's necessary because we're running this all in a simulated sort of VM environment. Then, so that's run that SSH, set up those tunnels as part of that SSH command, and then the actual command you run when you get to SSH, when SSH attaches to the machine, will be this. This does the Kubernetes port forwarding of the Nephio web UI service, port 7007. So this connects from the VM's local 7007 port to the container running in Kubernetes that provides the web UI. So that's kind of the little hops we have to do. This is obviously just because it's a demo environment, just because it's in a VM nested, a kind cluster nested inside a VM demo environment. In the real world, these would just be, you wouldn't do this at all. So we're going to run that, and this is what you'll need in order to, when you set up your environment, you'll need to do the same thing. To do that, we simply run this command, and we have to leave it running. So it's just going to stay, oops, I changed the name. So I need to change this. So we're just going to leave this running. We should see it connect in a second. There we go. So these messages forwarding, these are from the kube control port forward command. So we're just going to leave that there, and I have a second terminal here that's running. And for that second terminal, we are going to go back here, and we'll see that we have provided that command as well. Now the G Cloud Compute piece is when you're doing it with GCE for a vanilla VM, obviously you wouldn't need that. Okay, so I'm going to go back to the terminal, paste that in, change the name, and now we will be in, there we go, we're SSH'd into the machine. Oh, one other thing, let's go back to the UI for a second, to the browser for a second. So we set up those port forwardings. So what we're going to do now is we can go on our local machine to localhost :3000. That's going to give us GIT, and we can go to localhost 7000. You don't need that extra little bit on there. It'll happen automatically. And this gets you your Nephio web UI. So if you watch the demo video, this will look familiar. You can see we have our management repository already set up. We've got external blueprints registered here. So here's the GitT website and our user interface. If you sign in, it's Nephio and I think secret, all lowercase, and you can see that Nephio created this repository, and this is we don't actually ever need to go to this, but it's kind of nice to have it available as you're learning to see how things go. Okay, so in addition to doing it through GCE, you can also use a vanilla Ubuntu VM to do your demo. So what I have showing here is a terminal with that I created a vanilla Ubuntu VM, and you can see there's nothing on it yet. And what we're going to do is set this up in exactly the same way as we did for the GCE version of it, but we're going to do it with the vanilla VM. So going back to our UI here, you can see in the instructions, there's installing on GCE, there's installing on a pre-provisioned VM. Just like I said before, Ubuntu 20.04 Focal, 8 cores, 32 gigs of RAM, 200 gig disk size. User with sudo-less password permission. I think I have that. We'll find out. And this is it, really. It's basically, we're going to do the same thing that happened in the other GCE one. It's just GCE did it for us as part of the one command, but instead we're just going to execute wget, and we're going to pull down this init.sh, and we're going to send it into bash and let it do its thing. So let me let's give it a try. Hopefully I have sudo privileges. So copy that, switch back to the terminal, and paste it in. And it looks like it's working. So really, I mean, there's not much else to say here. It will work the same way. You'll have to SSH in, and you'll get your demo environment set up. And the next place to go from there is, once you've got your demo environment, is to take a look at our different exercises. So we have some exercises that you can go through. If you go back here, next steps, step through the exercises. So what does that do? It actually, just like in the initial demo video, if you watched it, it gets you through the process of setting up a complete topology that includes a regional cluster, 2 edge clusters, and a bunch of network functions running on those, and a UE RAN simulator to send a ping through to a simulated internet DNN. So that's all I've got for you today, and we'll be going through some of those different exercises in future videos. Please join us on Slack or GitHub, and hopefully we'll see you soon. Thank you. Bye-bye.